Introduction to Science and Hypothesis. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, visit LibriVox.org. This reading by Carl Manchester 2008. Science and Hypothesis by Henri Poincaré. Introduction by Judd Larmor. It is to be hoped that as a consequence of the present active scrutiny of our educational aims and methods, and of the resulting encouragement of the study of modern languages, we shall not remain as a nation so much isolated from ideas and tendencies in continental thought and literature as we have been in the past. As things are, however, the translation of this book is doubtless required. At any rate, it brings vividly before us an instructive point of view. Though some of M. Poincaré's chapters have been collected from well-known treatises written several years ago, and indeed are sometimes in detail not quite up to date, besides occasionally suggesting the suspicion that his views may possibly have been modified in the interval, yet their publication in a compact form has excited a warm welcome in this country. It must be confessed that the English language hardly lends itself as a perfect medium for the rendering of the delicate shades of suggestion and allusion characteristic of M. Poincaré's play around his subject. Notwithstanding the excellence of the translation, loss in this respect is inevitable. There has been of late a growing trend of opinion, prompted in part by general philosophical views, in the direction that the theoretical constructions of physical science are largely factitious, that instead of presenting a valid image of the relation of things on which further progress can be based, they are still little better than a mirage. The best method of abating this scepticism is to become acquainted with the real scope and modes of application of conceptions which, in the popular language of superficial exposition, and even in the unguarded and playful paradox of their authors, intended only for the instructed eye, often look bizarre enough. But how much advantage will accrue if men of science become their own epistemologists, and show to the world by critical exposition in non-technical terms of the results and methods of their constructive work, that more than mere instinct is involved in it. The community has indeed a right to expect as much as this. It would be hard to find anyone better qualified for this kind of exposition, either from the profundity of his own mathematical achievements, or from the extent and freshness of his interest in the theories of physical science, than the author of this book. If an appreciation might be ventured on as regards the later chapters, they are perhaps intended to present the stern logical analyst quizzing the cultivator of physical ideas as to what he is driving at, and whither he expects to go, rather than any responsible attempt towards a settled confession of faith. Thus, when M. Poincaré allows himself for a moment to indulge in a process of evaporation of the principle of energy, he is content to sum up, quote, Eh bien, quelles que soient les notions nouvelles que les expériences futures nous donnèrent sur le monde, nous sommes sûrs d'avance qu'il y aura quelque chose qui demeurera constant et que nous pourrons appeler énergie. End quote. And to leave the matter there for his readers to think it out. Though hardly necessary in the original French, it may not now be superfluous to point out that independent reflection and criticism on the part of the reader are tacitly implied here as elsewhere. An interesting passage is the one devoted to Maxwell's theory of the functions of the ether, and the comparison of the close-knit theories of the classical French mathematical physicists with the somewhat loosely connected corpus of ideas by which Maxwell, the interpreter and successor of Faraday, has, posthumously, recast the whole face of physical science. How many times has that theory been rewritten since Maxwell's day, and yet how little has it been altered in essence, except by further developments in the problem of moving bodies, from the form in which he left it. If, as M. Poincaré remarks, the French instinct for precision and lucid demonstration sometimes finds itself ill at ease with physical theories of the British school, he as readily admits, and indeed fully appreciates, the advantages on the other side. Our own mental philosophers have been shocked at the point of view indicated by the proposition hazarded by Laplace, that a sufficiently developed intelligence if it were made acquainted with the positions and motions of the atoms at any instant, could predict all future history. No amount of demur suffices sometimes to persuade them that this is not a conception universally entertained in physical science. It was not so even in Laplace's own day. From the point of view of the study of the evolution of the sciences, there are few episodes more instructive than the collision between Laplace and Young with regard to the theory of capillarity. The precise and intricate mathematical analysis of Laplace, starting from fixed preconceptions regarding atomic forces which were to remain intact throughout the logical development of the argument, came into contrast with the tentative, mobile intuitions of Young, yet the latter was able to grasp by sheer direct mental force the fruitful though partial analogies of this recondite class of phenomena with more familiar operations of nature, and to form a direct picture of the way things interacted, such as could only have been illustrated, quite possibly damaged or obliterated, by premature effort to translate it into elaborate analytical formulas. The aperçus of Young were apparently devoid of all cogency to Laplace, while Young expressed, doubtless in too extreme a way, his sense of the inanity of the array of mathematical logic of his rival. The subsequent history involved the nemesis that the fabric of Laplace was taken down and reconstructed in the next generation by Poisson, while the modern cultivator of the subject turns, at any rate in England, to neither of those expositions for illumination, but rather finds in the partial and succinct indications of Young the best starting point for further effort. It seems, however, hard to accept entirely the distinction suggested between the methods of cultivating theoretical physics in the two countries. To mention only two transcendent names which stand at the very front of the greatest developments of physical science of the last century, Carnot and Fresnel, their procedure was certainly not on the lines thus described. Possibly it is not devoid of significance that each of them attained his first effective recognition from the British school. It may in fact be maintained that the part played by mechanical and such-like theories, analogies if you will, is an essential one. The reader of this book will appreciate that the human mind has need of many instruments of comparison and discovery besides the unrelenting logic of the infinitesimal calculus. The dynamical basis which underlies the objects of our most frequent experience has now been systemized into a great calculus of exact thought, and traces of new real relationships may come out more vividly when considered in terms of our familiar acquaintance with dynamical systems than when formulated under the paler shadow of more analytical abstractions. It is even possible for a constructive physicist to conduct his mental operations entirely by dynamical images, though Helmholtz, as well as our author, seems to class a predilection in this direction as a British trait. A time arrives when, as in other subjects, ideas have crystallized out into distinctness. Their exact verification and development then becomes a problem in mathematical physics. But whether the mathematical analogies still survive, or new terms are now introduced devoid of all naive mechanical basis, it matters essentially little. The precise determination of the relations of things in the rational scheme of nature in which we find ourselves is the fundamental task, and for its fulfilment in any direction advantage has to be taken of our knowledge, even when only partial, of new aspects and types of relationship which may have become familiar perhaps in quite different fields. Nor can it be forgotten that the most fruitful and fundamental conceptions of abstract pure mathematics itself have often been suggested from these mechanical ideas of flux and force, where the play of intuition is our most powerful guide. The study of the historical evolution of physical theories is essential to the complete understanding of their import. It is in the mental workshop of a Fresnel, a Kelvin, or a Helmholtz that profound ideas of the deep things of nature are struck out and assume form. When pondered over and paraphrased by philosophers, we see them react on the conduct of life. It is the business of criticism to polish them gradually to the common measure of human understanding. Oppressed though we are with the necessity of being specialists, if we are to know anything thoroughly in these days of accumulated detail, We may at any rate profitably study the historical evolution of knowledge over a field wide